So in this lesson, we're going to investigate how to solve recurrences of the form that come up from divide and conquer algorithms, such as the one shown here. T of n is equal to 2t of n over 2 plus c, and when n is 1, t of 1 is just equal to d. The method we're going to use is the method called a recursion tree, and the idea is that we build a tree whose sum of values of the nodes will equal the solution, the closed form solution for t of n. So let's start off with a degenerate tree where the only node in it is a single node which has value t of n. Now we can replace this by looking at the formula, which says that t of n is actually 2 times t of n over 2 plus c. So we can replace t of n with 2 copies of t of n over 2 plus a c. Now there's nothing special about n. We can apply the same formula to n over 2. And by substituting n over 2 in for n in the formula, we'll see that t of n over 2 is equal to 2 copies of t of n over 4 plus c. And similarly here. Well, I'll bet you can't guess what's going to happen next. Exactly, we can replace t of n over 4 with 2 copies of t of n over 8 plus c, and so on. Okay, so there's no need for us to continue expanding this because we can imagine what's going to happen. It's going to eventually span out until we get down to the very bottom level where we'll have t of 1. And we know that t of 1 is equal to d. So in order to figure out the sum of the values in this tree, we need to know a little bit more about it. In particular, we need to know how many levels there are in it, how much, what the value is at each level, and so on. We can do this by doing just a little bit of bookkeeping. So let's write down the level, the number of nodes at that level, what is being represented at that level, we're taking t of what, the value at a node, and then finally the whole sum of the values at all the nodes at that level. So at level 0, there's one node, we're taking t of n, the value at that node is just c, and the total is c then. But at level 1, there are 2 nodes, we're taking t of n over 2. The value again at each node is just c, and the sum is 2c. At level 2, we've got 4 nodes. We're taking t of n over 4. I'm going to write that as n over 2 squared. The value at the node is again c, and we've got 2 squared c. At level 3, there are 2 cubed, or 8 nodes. We're taking t of n over 2 cubed. There's c at each node, and the total is 2 cubed times c. And in general, at the kth node, the pattern should now be clear. At the kth level, the pattern should be clear. There are 2 to the k nodes. We're representing n over 2 to the k. Each node has value c, and the total value at that level is just 2 to the k times c. So one question that arises is, what is the value of k at this last level? In other words, when we get down to t of 1, when we're down to t of 1, what is the level? What is k? And we can figure this out by solving for k when n over 2 to the k is equal to 1. So we have n over 2 to the k equals 1. And so what level k is that? Well, it's not hard to see that that's just k equals log of n, where the log is base 2. So let's just use that, log of n. There are 2 to the log of n nodes. Again, each one has value c, and total there's 2 to the log of n. Oops, sorry, each one has value d, because we're at t of 1. And so the total value is 2 to the log n d. Excellent. So now we have a pretty good idea of exactly what's going on in this tree. So our tree looks something like this. There's a whole bunch of C's. At the bottom, there's a bunch of D's. The last level is log of n. The next to last level is log of n minus 1. The kth level has 2 to the k times c value, and the first level is level 0. So the total value in the tree is a sum. The value is just the amount in the leaves plus the amount in the non-leaves. Well, how much are in the leaves? Well, there's log of n, so there's 2 to the log n nodes, each with value d, which is just equal to n times d. In the non-leaves, the value is obtained by a simple summation where we sum the value at each level. And so here we're taking the summation where the level k goes from 0 to the penultimate level, log of n minus 1, of 2 to the k times c. Now this is not hard to simplify. We have nd, and now from our summation, let's pull the c out in the front and factor out the c, and we end up with this summation, which is a geometric series. And you can simply apply the formula for a geometric series with ratio 2 and first term 1, or you can know this special case where we're summing successive powers of 2, starting at 2 to the 0, and the special case says that the sum of a bunch of special powers, sum of successive powers of 2 is just the next power of 2 minus 1. So we'll use that, and we end up with nd plus c times 2 to the log of n minus 1, which simplifies to c times n minus 1. And so our final expression, if we collect terms, is n times c plus d minus c. And that's the solution.